Welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about outliers in a distribution. So let's get started by talking about a box plot. Okay, so let's go. What a box plot does is it kind of just separates the data points into like 25%. It separates it into quarters. And then this middle line is the median, the 50th percentile. So this is 25%, this is 25%, this is 25%, this is 25%. That's how easy it is to read a box plot. So the start of Q1 here is at 25% of the data point, and the end of Q3 is like, what is this? This is 50%, and this is 75%. So Q3 is 75% through the data point. So the start from Q1 to Q3 is 50% of the data points. It's the middle 50% of the data points, so it should be the least variable. They should all be the closest together. Okay, now we have to talk about outliers. Box plots do this nice thing, like if you make them on your calculator, they do this nice thing where they do little stars for outliers. So we know, like, if this was a graph, we'd have two outliers. I just wanted to point that out to you, and that quarter 1 to quarter 3 is the interquartile range. Interquartile range just means the range of the middle 50 points. Like, so we know from Q1 to Q3, it's 50 points. Well, 50% of the points. So what this is saying is Q3, like minus Q1, we'll just say, like this over here is kind of like what Q1 is, and then it starts here. So Q3 minus Q1 will give us the range of both of these boxes, so the middle 50% of points. Now, what we get to do with that is say this interquartile range is equal to quarter 3 minus quarter 1. Now, what you can do with that is find outliers. So a low outlier will be less than quarter 1 minus 1.5 times the IQR. So it's the low, like this is quarter 1 here, like this is already 25% of the points, 25th percentile, minus 1.5 times like the variability of the middle 50 percentile. So it's like out there. And then if it's lower than that, that thing is an outlier. Okay, so low is less than quarter 1 minus 1.5 times the IQR, and then high is greater than quarter 3 plus 1.5 times the interquartile range. So if you got that, let's go to an example. You can do this in your calculator, by the way. I'm just not going to. I'll do it by hand just to show. So our data set has 10 points. We have 2, 3, 4, 7, 7, 8, 8, 8, 14. So let's get started with finding our Q1, our quartile 1. Like I said, quartile 1 is the 25th percentile. So 25% of points are like less than it. So since we have 10 points, I know that each of these points is 10%. So this is 10%, 10%. This is really 20%. And then this is 30%. So I'm going to take the average of these 2 points just to get like more accurate. And Q1 equals 3.5. Then I'm going to go from the back here. You could count up to 75%, but I like going down. This will be 100%, 90%, and then 80%, and 75%. So 75% will be 8, which if I did that counting wrong, it's all right because I made sure it would be 8. So now we are going to find our interquartile range. So our IQR equals 8 minus 3.5, which equals 4.5, I believe. Now we're going to say, okay, quarter 1 is 3.5 minus 1.5 times 4.5. Well, you're not really, if you subtract, even if you subtract 4.5, you're going negative. So there are no low outliers here. Now, if we look at 8, right, and we try adding 1.5 times 4.5, half of 4.5 would be 2.25. So 4 plus 2.25 equals 6.75. And if we add that here to 8, we will get 14.75. Now, if we look, that is like the number, the cutoff of outliers. So if we look at 14, which you might have thought was an outlier to begin with, if we really look, it's not an outlier. 14.75, so high must be greater than 14.75, and since 14 is lower than 14.75, it is not an outlier. So we could say this distribution has no outliers. Thank you for watching. Please like and subscribe if this video was helpful. I really appreciate it. And please comment if you just want to chat or ask some questions. So thank you.